Hello and welcome to this series of an overview on precast construction technology. So in this video, we will discuss about the advanced construction technology. So in this series, we have already covered various topics such as we have discussed like construction of the precast hollow core slab. We have also discussed all about the precast wall panels, then precast column, precast beam, and so in this video we'll see the overview of the precast staircase and landing. So let us first start with the process. So the process that is involved in the precast construction technology, that starts with the concept and planning, where the elements are or we can say the structural part or the main precast elements are splitted into a number of elements that will be feasible for erection as well as for the logistic purpose. So the main part is the concept and planning, where the precast elements, each and every individual elements will be pre-planned according to its size and all the parameters. Next it comes is the design and production of the element, in which after the concept and planning, the elements will be designed and then the element will be produced in factory, right? And then it is stored in the stockyard, and when there is a requirement of the precast element, then it is transported using the special logistics depending upon the element type and its size, weight, and other parameters. And after the logistics, it comes the erection comes into the picture, where elements are erected to the site using the tower crane, and also sometimes it is the requirement of the mobile crane, where there is a critical situation where we cannot use the tower crane. So there are possibilities of using mobile crane as well. And lastly, after the erection, the erection crew or erection team will finally have the finishing work, and then it will be hand over to the client, where all the finishing and joint connection details, and then sealant work between two precast elements or precast to cast in situ elements, everything is covered. And after that, it is hand over to the client or maybe contractor. So there are many, or we can say there are various precast elements that can be done. We have already seen in this series, we have already seen the overview on hollow core slab. We have seen overview on the precast beam, then pre-stressed beam, and the columns and wall panels. And in this video we will see the precast staircase and landing. And other than that, we there are also a special kind of elements which can be constructed using precast construction technology, because uh, it is said that concrete is like water in the field of precast, in which the concrete can be maintained, or we can say the concrete can be shaped in any of the form we want. So it is very flexible, in which we can make a special kind of elements as well. So in the first picture, on the first picture left hand side, you can see this is the hollow core slab that we have already seen in the first video of this series. Then in here you can see precast beam and column, that is a frame structure. This we have covered in our second video and third video of this series. And so in this video we are seeing the precast staircase and landing. So here you can see this is the site, and this is the already precasted element that is they are installing at the site. So here you can see these are the four lifting points that are placed in precast element before concreting. So we'll see all these details in brief in our further slides, in which we'll discuss the mold preparation, as well as the what kind of liftings are provided, how it is connected structurally with the other elements, how the load is distributed, etc. And Last but not the least, so we have the special kinds of elements such as the dome structure. So in this figure you can see this is the dome structure in which the elements are splitted into number of elements depending upon the concept and planning. So we have discussed, we have seen in the process that the first step comes into the picture is the concept and planning, where this elements will be where the element type and its weight and everything will be decided, and then it will be approved for the design as well as the production. So not only the dome structure, we can also make a special kind of elements depending upon the requirement. That is with the collaboration of the structural engineers. So in this video we are going to flow through the precast staircase and landing process, in which we will see how the elements are made, and up to the erection we will discuss all the points. So here you can see in the figure or in the picture, you can see this is the precast staircase. Here you can see this is the precast staircase, and here you can see one of the small pockets are given. Two pockets are here, and similarly the two pockets will be placed over here. So this pocket is known as the lifting point, in which this lifting point will be used for the erection purpose. So we will cast while casting this kind of elements, we will cast it upside down. In that case, the steps will be casted below, and the soffit of this staircase will be on the fair face, or we can say this is my mold face. So this is the mold face of the element, and this is the fair face. This is the fair face. So it is casted opposite. It is casted, we can say it is casted up, it is rotated while it is casted. So here you can see this is in this picture it is clear that this, you can see this is the landing. There are two landings with the single flight. So in the center this is the stair flight. There is one landing, this is landing 1, and in the bottom side this is landing 2. So there can be a different case in the staircase. For example, let us say this is the number 1 type, or we can say this is the type 1 staircase, in which it only has the flight. So this is the flight starting from here and ending to here. So this is the only flight. It can be flight plus landing. So if we say this as type 2, so it is flight plus landing. So in that case this is the flight, and we have landing 1 and we have landing 2. So that can be a two different type of panel, type of element, depending upon the requirement. So let us discuss how this process begins. So the step 1. So in the step 1, we can say in step 1 the preparation of the mold and the reinforcement cage will be prepared. So in this step, as per the size of the precast staircase or landing, we will make the mold, and side by side the reinforcement cage will be prepared by the team, in which all the accessories will be tied up. Coming on to the second stage, the prepared mold will be inspected by the QC engineer before placing the reinforcement into it. So after the approval of the QC for the new mold, then the reinforcement is placed into the mold that is prepared and QC checked by engineer, and then all the accessories, or we can say all the required lifting points, will be tied up, and then the concreting will be done. So after the concreting, it will be lifted and it will be delivered to the site. So that was all about stage 2, and coming on to the stage 3, the element is then transported to the site as per the requirement, and then it is lifted using the 4 lifting points that are fixed at the time of casting that element, and then it is erected using the tower crane. So here you can see this is the tower crane that is used, and it will be placed over here. So here you can see this is the nib portion. We have discussed what is nib in the wall panel. So this is the wall panel. So here this structure is the wall panel, and in that we can see this is the nib. So this is the nib in which this part of the staircase, this part of the staircase will be resting on this part, and this another end of the staircase will be resting on another nib that will be provided here. So this is how the staircase with landing are connected to the wall panel using the nib connection. So now let us see, this is the mold preparation. Here you can see this is the mold that is prepared for the precast elements. So here you can see this is the landing one. So this is the landing part. Second is the flight that has these steps on it, and third it is here you can see this is the landing two. So this is the third part. So it will be like if I say so this is my landing, this will be the landing, so this will be the flight, and again there will be a landing. So it is considered, it is something like this. So here you can see it is casted opposite side. So you can see the steps are on the bottom side, and this is the soffit. So the soffit is on the upward side, and here you can see the groove, or we can say the box is placed in position. This is because to create a nib in the staircase, or we can say in the landing. So on the top side also you can see this will be the nib, this will be the nib that will be casted, and here this is the nib portion that will be casted. The purpose of the nib is to connect the another flight. Here let's say there is another flight coming coming from the down, and there is another flight that is going to the upward side. So to rest and connect the other flights or landing, the nib is provided to connect it in between. So now let us see figure B, which is on the right hand side, that is the precast staircase installation. So here you can see this is the individual landing that is used. This is individual part, where in this figure A, we have seen it is the combine, that is landing plus flight plus landing, that is 1, 2 and 3. So it is the one structure or one unit is there. So in this figure you can see this is the part 1, which it is an individual component, that is the individual landing that is casted, and we have a single flight. So it is an individual element. So there is you can see there are some plates that is connected, that is used for the connection of the flight and landing. As well as you can see clearly here we have the lifting point 1, 2, as well as we have point 2, or we can say point 3. So 3 lifting points are given here. So now this all lifting details we'll see in our further slides how it is connected. So now after doing the concreting and all the things, you can see this is the finishing of the precast element. As I told you, the precast elements are casted opposite. So you can see this steps portion are on the bottom side. It is casted upside down. You can see this is all the upside down structure, and this is the soffit part. So this is the reason for casting this kind of elements upside down is that we will get it is easy to make the mold for the steps, and the top side, which is the soffit side, we have to just make the finishing. So it will reduce the overall time of the concreting work and machinery work. So also here you can see this is the nib portion, or we can say this is the nib, this is the concrete nib that is used for the connection detail. And here you can see this is the lifting point that is provided for the lifting of the elements, as well as sometimes the side liftings are also provided for the demolding purpose. There are two types of liftings that are provided. First, let us discuss this side liftings are known as the demolding lifting, and on the lifting that is provided on the steps, or we can say on the top side, that is for erection purpose. So there are two different types of lifting and its purpose. So now let us discuss the lifting accessories that is used for lifting of the precast elements for the purpose of demolding as well as for the purpose of erection. So here you can see this is the lifting deha that is used, or we can say this is the lifting anchor that is used in position. And this on the and on the top you can see this is the rubber type of material that is known as the recess former. Recess former means here you can see there is a cup shape, or a cup shape is there. So that shape is created by the this kind of rubbers that is known as the recess former. Clearly in this picture you can see this blue color is the recess former, and this is the anchor that is fixed in position. So after the casting, after the concrete is dried, this rubber former, or we can say recess former, will be removed manually. So here you can see in the figure lifting clutch, this here you can see this is the cup shape that is formed, and here you can see this is the anchor that is placed in position. So now to lift this element using this anchor, we will use the clutch. So here this in this figure you can see this is the clutch that is used for lifting the element that will be connected with the anchor. So this is the so here you can see this is the clutch, and here you can see this is the anchor that is locked using the clutch, and then it will be lifted. If we talk about the fixing of that particular anchor, so here you can see the anchor is placed in position with the recess former, as well as this kind of U bar. You can say this is the U bar. Here you can see this is the U bar used on both of the ends to lock this anchor. So if we can say there will be a U bar coming from here to here, and another U bar that will be locked like this and like this. So that will that will not allow the slippage of the particular lifting point. And yeah, this is the main purpose of providing the reinforcement that is as per the IS standard. So it says that approximately 2 times the length of the leg has to be provided. Basically that we have already seen that there can be two different types of staircase that can be done. So let us say a precast staircase can also be used with the RCC structure. So here you can see this is the brickwork, or we can say this is the RC elements that can be used with the RC elements, as well as on the figure B we have the steel structure, where we have the steel columns, beams and everything. So it can be suitable with the precast, it can be suitable with the steel structure also. So if we talk about the steel structure, this is the separate landing that is casted. So this can be known as the mid landing, and this can be known as the floor landing. This is the floor landing. So mid landing, it is rested on the steel beam. Here you can see this is the steel beam or steel frame structure that is connected with the landing, and then after that the particular flight is rested on the landing like this. So let us see the different components and of the staircase. So here you can see the yellow marking is the flight or individual flight that is uh, connected with the mid landing. So there is a connection between the flight and landing. Again here flight and landing, and again here we have the connection with the flight and landing. So this is the mid landing, this red is the mid landing that is resting on the steel beam, that is the steel structure, or it can be an RCC structure. In case of RCC structure, we have the wall. So in the wall, let us say this is the wall. So in the wall we will have the nib, and let us say this is the precast landing. So that precast landing will be rested on the nib, and it will be connected with this RC structure. Now this now on this landing there will be a staircase. So there will be a flight that will be set on this, and there will be another flight that will be moved on the top. So this is how these two will be connected with each other. So now here you can see in this picture it will be cleared how the landing and staircase are fixed. So here you can see this is the RC structure, and this is the landing part. This is the mid landing. You can see this is the mid landing that is rested. So in the below there will be a nib here. So in this wall there will be a nib in this portion. Actually there will be a nib below in this portion. So this is the landing. This is the mid landing that is connected, and then this is the flight that is coming from the down, and this is the flight that is going upward side. So and also this is the landing. Actually this part is also landing. So in the landing there will be a nib, as we were discussing. This is the nib portion. This is the nib portion in which there will be a dowel bar that will be projected from the nib of the landing, and then the staircase will be connected, or we can say this is the flight that will be connected with this kind of connection detail. And here you can see this is the lifting point that is provided. So in this picture it will be very much clear. So this is the case where we have the landing plus this is the case in which we have flight plus landing. So this is my flight, this is the flight portion, this is my landing, and this is also landing. So this is landing, flight, landing. So this is the combination of flight plus landing. So here you can see the zoom portion of the lifting point that is given here. So this is the clutch and anchor that is used. Anchor is fixed in position and clutch is used to lift the elements. This is the clutch and this is the anchor that is that will be useful for lifting of the precast element. So now here you can see this is the splitted element, in which this is a particular single piece for the landing, that is the floor landing, and we have individual precast staircase that is fixed with the landing. So there will be a connection between landing and flight. So here it is clearly seen, this is the landing, and in this flight will be connected with the this nib. So here you can say this is the nib, and now for the above floor there will be a flight that will be connected like this. So now let us move on to the product tolerances as per the manual 135, that says about the tolerance manual for precast and pre-stressed concrete construction. So here you can see this is the plan of the staircase, and this is the elevation of the staircase. So in that case, A, that is the length. So the tolerance for the length can be plus or minus 13 mm, that can be allowed. Width of the staircase, that is the B, that can be allowed as plus or minus 10 mm. Then we have the B1, that is the individual trade width, or we can say we have the trades. So trades could not be plus or minus, shall be in a limit of plus or minus 6. C is the overall depth. So this is the overall depth of the staircase, that should be in a limit which is plus or minus 6 mm. C1, we have the C1 is the individual riser depth, that should be in limit of plus or minus 5 mm. This is we have the C1, this is we have C2 that we have discussed. So the C2 is the riser variation, that should be plus 3 mm or minus 0 mm, or we can say 0 mm. That should not be tolerance, or it should be plus 3 mm. Then we have C3, that is the difference in the height between the adjacent riser, that should be in a variation of plus or minus 6 mm. And so this all are the parameters that are given as per the as per the manual 135, right? So you can go through this manual once, where you will see all the tolerances that is given. And yes, so this is the landing, and this is the flight. So in the landing, you can see this is the opening that is provided. Opening means this is the cutout that will be provided for the passing of the MEP or any fire lines or anything. So for that, we can also make a provision of the opening as well. If we talk about the other products, we can also produce the other special kind of products for in using the precast construction. So in the figure B, you can see this is the solid slab, that is the cantilever solid slab. So that can be made using precast. Then we can also make pre-stressed solid slab. This is the precast solid slab. First one is the precast solid slab. This is the pre-stressed solid slab, in which the strand wire is used in case of heavy loads. Then we can also make the precast footing depending upon the requirement. And last but not the least, we can also make the precast boundary walls. So this was all about the precast staircase and landing. So if you haven't watched the other videos on this series, we have hollow core slab video, we have precast wall panel, we have precast column, we have precast and pre-stressed beam, as well as we have all made many videos on precast technology. So if you haven't watched this series, so you can, I recommend you to go through this video. And that was all about this video. So if you liked this video, just subscribe and give me a thumb. Thank you so much. Thanks for watching. And that is all for today. Thank you.